Hello dear students, today we are solving the ISI M.Tech CS paper 2025 one here at the C5. It's a model paper. So we have to solve in for any undirected connected graph G, let chi G be the minimum number of orders needed in these varieties and G, and we have to prove that for every vertex V on G there exists a path of length of this and the path of length G in the sequence K plus 1 in the distinct variety such that this is this. Okay. So we are given an undirected connected graph with this is actually the chromatic number. Okay, this is the chromatic number which represents the minimum number of colors needed to properly color the graph, such as the two adjacent varieties share the same color. So every vertex V in G, so our goal is to prove that every vertex V is in G. Okay, so there exists a path of length chi G minus 1 starting from V. So the key definitions of understanding the problem: what is a chromatic number? It is the minimum number of colors needed to color the graph properly. Here chi G equal to K. Okay, chi is equal to K. So there exists at least one K click or K partite structure that enforce this requirement. So now path of length K. So since K plus 1, this is the K plus 1 distinct vertices like V1, V2 dot 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 Vk plus 1 is there, such that each consecutive pair Vi and Vi plus 1 is an edge on G. So is on edge on G. So the a path of length K consists of K edges. Okay, so this consists of K edges. So our goal is we need to prove that any vertex, in this case xg minus 1, it will follow this path. Okay, so first we have to understanding coloring of the graph structure. So the coloring of the graph means a valid coloring. In this case on G, on this graph, means that each color class forms the independent set, that is two independent vertices. So here G is connected, here G is connected. That means it means between two different color classes there at least one edge will be there, and the chromatic number suggests that some part of the G is structured in a way that the demand at least xg colors, so at least xg number of colors. So this often arises from a subgraph that the properties of the complete xg partite graph or a xg click. So constructing the path, so we have an optimal coloring with xg colors, and we aim to find the sequence in xg in different vertices. Okay, different vertices we need to find out. So starting from the vertex, assign same color to C1. Then G is connected. So at least one neighbor of the V2 with a different color, V2 with a different color. Okay. So since the graph is at least xg colorable, so we can extend this path to xg minus 1 steps. Now ensuring the path xg is long, so at worst we can conduct. Okay, so the structure of xg of colors, we form the covering xg with distinct vertices. So that is again chi G, actually xg I am saying. This is the number of edges since path of length K consists of K plus 1 vertices. So hence this is the case, and we prove the required result.